That's really fast. 3, 2, 1. It's just once. 3, 2, 1. It's got to be loud. 3, 2, 1. 1, 1, 1, 1. At a count of 2, can I hear you guys clap loud twice? So we create a rhythm. 2, 2, 2, 1, 1, 2, 1, 2, 1, 1, 1. So that really tells me that you guys are back for the session now. Alright, yes, ladies and gentlemen, once again a very good afternoon, welcoming you all to the second half of Day 3 Cypher 3rd edition. We call it as Cypher2017. The topic for the session, the topic for the last session here at this particular space, this particular hall is data scientists or developers leveraging advanced platforms to automate deep learning tasks. And yes, the speaker will conduct a workshop on this particular topic. Deep learning enables the apps or systems to learn and adapt from data quicker and easier. Currently, for enterprises who are trying to adapt to deep learning, it is a time-consuming and expensive task. In this workshop, the speaker will discuss about various platforms in the market and how they assist enterprises in achieving the broad business goals using artificial intelligence driven by deep learning. Ladies and gentlemen, a quick note about the speaker. He is a CEO. He is the CEO and the founder of an organization, an enterprise which is into deep learning, and it's a startup. Started off in the year 2013. The organization is one of the most innovative deep learning startups globally, enabling enterprises to build next generation products using deep learning. He is the youngest member of AI task force set up by Commerce and Industry Ministry, that's Government of India. He is also listed in Forbes Asia, that is 30 under 30 in technology for 2016. He is a regular speaker at multiple global technology and industry conferences like GTC, NVIDIA, Rework, NASSCOM, etc. He is currently the CEO and founder of an organization that is Arya.ai, ladies and gentlemen. With a thunderous applause, let's welcome Vinay Kumar.
Good afternoon, everyone. Thanks for the introduction. And 1 second. Yep. Anyways, I know that afternoons are always lazy, right? You have good food, good ice cream. Ice cream is good. I just had the ice cream. Not too much food because I have to talk, right? It's different from you versus me. I have to talk, and I have to talk for almost an hour. So I just kept it very light. And I don't want to bore you so much. Too much technicalities, don't like. It's more toward, this talk will be more towards what's happening in deep learning and what are the kinds of tools that are coming into the market. Very few amount of tools, not too many tools that are available in the market anyways, right? We'll be talking about how does a product design would happen in deep learning and how does that impact long-term strategy / short-term strategy in any company, right? And as few people might have already known what we are, so we are primarily a deep learning platform, enabling enterprises and developers to build products primarily using neural networks / deep learning and make it quicker and faster so that we could see many people adopting to deep learning. So that's the key goal of the company that we have set up. And quick background, I just don't want to be too self-esteemed. So we started off in 2013, very early phases of deep learning. Not many people knew about deep learning at that time. And we have been doing a lot of research even before coming a product. So we started in 2013 and our product was launched more or less in mid 2016. So about 3 years or so, we completely invested in research. We wanted to understand what could happen in deep learning. So we don't want to build a module or we don't want to build a solution. We thought it is beyond that. Deep learning is always beyond that. So deep learning is one such technology that can help many people. So we wanted to become that enabler, meaning why can't anybody who doesn't even know about deep learning, can we enable them to use deep learning? So that's the key goal of the company that we have set up. And today we are primarily researchers from IIT Bombay, UCLA, ICR, primarily researchers from all over the world. And now we are expanding in different global markets. So we are already kind of working a lot of financial institutions in India, and we have a lot of customers in Europe and UK, and US is where we have a lot of partners. And Arya in deep learning, so this is more or less outlines the product stack slash offerings of Arya in deep learning. So one is Braid. Braid is a meta framework that we have launched. It's an open source framework which is comparable to Keras, and we are the only startups in India, or slash company in India who has our own framework. And Vega is a workbench primarily for enterprises wherein they can plug in and start building models. And then above the platform, we have vertical applications. Applications meaning solutions. The reason why we have built this solution is primarily to give the value of the platform in a quick amount of time. For example, even though you can use the platform and build the product by yourself, some things that we have seen in the very early phases is ability to use the platform and build a product in a short amount of time. So for that reasons, we built industry level solutions on the platform so that you can extrapolate the value and you can see the value from day zero, right? For example, if you come to Arya and if you are a bank, you already have 3 solutions which you can start using it. Or if you are an insurance company, so you have another 2 solutions which you can leverage. If you are a manufacturing guy and you have a requirement for large scale IoT slash intelligent IoT requirements, you have another 3 applications which you can start plugging and building. And then we have built multiple APIs, primarily supporting developers slash startups who don't have datasets, wherein they can just start consuming the APIs and start using those modules. And today we are working with some of the leading names in the industry. For example, we recently closed a partnership with Google, and then we are now working with NVIDIA and also Oracle very recently actually. So we're going to work with Oracle Singapore team. So we have the key goal of this partnership is again democratizing AI, democratizing deep learning, right? So today deep learning is very much known in large scale industries or large scale companies like Google, Facebook, Microsoft, but there are a lot of other industries or other enterprises who might not know how to build it, or who might not have access to the talent, or who might not know how to build a good production system. So there is a huge gap between the demand versus supply, right? So that's where we wanted to bridge that gap. So democratizing AI is our key goal that we are trying to achieve through these partnerships. So some of the challenges in deep learning, right? For example, today, the first challenge is the scarcity of the talent. So there are very few people globally who could able to use neural networks to solve new problems. I'm not talking about data scientists who are using open source modules and then customizing them in somehow. So for any industry problem, you might have to start from scratch many times, meaning you might have to solve and build a neural network from scratch. So in that case, you need people who could able to build neural networks and who could able to build a new architectures. And the prerequisite requirement for deep learning is pretty high. For example, today to build a deep learning product or even a model, you need to know, you need to have understanding about the frameworks. You need to have understanding about environments and deployment architectures. And there are huge trade-offs with the current solutions. We'll talk about few of those. And there is increased complexities between task level versus high functional. For example, today everybody talks about task level API, right? I have one neural network, I train it on one data set, and I'm creating an API out of it. So that's a simple task level. For a high functional level, so one API is doing multiple tasks, which might be an outcome of multiple neural networks. In that case, your complexities kind of becomes exponential. And there is a dynamicity in the deployment environments. For example, today GPUs might be standard, and there is a huge amount of innovation that is happening in the hardware and also in the cloud environments, which can support your latencies, which can support your throughputs, right? So as a user, you might have plenty of options to play around with. And then there is learn and relearning concept. For example, if I build a module or an application, is it learning on the live or is it adopting on the live? For example, I have built a model on, let's say, last 1 year's data, but I'm gathering new data set every day. Can I retain the model autonomously, right? Your data set is kind of dynamic, which is varying with the time, but your model is static. You have trained the model on the previous data and just relies like that. And there is a short-term / long-term product strategy, and there are give and takeaways. So as I said, to go deeper in those problem statements, for example, today deep learning expertise are pretty scarce, right? So this is just estimated numbers. Again, it might vary depending upon the assumptions. So today there might be about 8,000 to 12,000 experts, primarily researchers / high-end people who work sort of university or who work sort of R&D companies. And then there are 85,000 plus people / probably around 50 to 80,000 is what our estimations are. Primarily the beginners are people who can understand neural networks and start building small scale neural networks. And the requirement is pretty huge, right? Any data science requirement can be considered as a deep learning requirement. At the same time, it might not be vice versa, but still the demand is pretty huge, and we are seeing continuous gap between the demand versus supply going forward. For example, in next 5 years, every company wants to use AI, every enterprise wants to use AI, every startup wants to have a product with intelligence behind it. So any company that is that already being there and any company that is coming up in future, the primary requisite of all of them is having a data scientist or having a deep learning guy in-house. So the demand is going to be a pretty huge in terms of what people are expecting and how many people would be required. But that might not be matched up with the pace where talented people are coming out into the market, right? So there are a lot of programs slash efforts that is being put into such that people can understand and people can be educated with deep learning. But still the gap is going to be pretty huge going forward. And then as I said, expertise on multiple skill sets. So today you need expertise on frameworks, like do you want to use TensorFlow, do you want to use Torch or Caffe? So what framework do you want to use, or do you want to use and then there are meta frameworks libraries, right? And then there is HPC, high performance computing and environments. Is it NVIDIA GPUs? In NVIDIA GPUs there you have multiple configurations, like Voltage is a new one, and then you have PC Pascal series, you have Tesla series, you have all these multiple series of GPUs, and then Intel is launching new hardware, GPU is launching, Google is launching new hardware for using TPUs. So there is a huge amount of volatility in terms of choice of deployment environments. And then expertise in DevOps. So which cloud environment should I use? Should I use Google Cloud, or should I use Amazon Web Services, or should I use some other cloud environment? Again, this is all the expertise that would be needed as a prerequisite to build a product, right? So this is where it takes a lot of time in any enterprise to go from building a network to going to production. Again, this is where we are seeing a lot of challenges, meaning we have heard that a lot of enterprises are using neural networks somehow, but not many of them are going to production. So production is different from building a model. Building a model might not take that much time, but going to production meaning you have to handle a lot of things. And at the same time, going to production also means your model needs to have certain performances. For example, if it is an image classification problem, right? So what people would typically do is they use all the open source architectures like AlexNet or GoogleNet, and you have all these neural networks which is already there in the market. Use them and try to customize them, and then get accuracies of 90 to 93, 90 or 85 to 90, something of that sort. But 85 to 90% accuracy is not good enough to go to production. So you have to have the best accuracies, the best precisions at least, for any enterprise to go to production. So that's where huge time requirement will take into picture. It's easy to say that we are using deep learning, but it takes a lot of effort to say that our deep learning product is in production. So there are multiple current solutions available in the market, but they have their own trade-offs in its own perspectives, right? For example, frameworks will give you a lot of flexibilities, but it's very tough to use. And then there are data science platforms who are trying to address and try and solving the same problem in deep learning, but they are not designed for deep learning based tasks. They're designed for machine learning / statistical modeling tasks. And then you have APIs, but again, so APIs are highly limited with the use and highly limited with the training data sets. So these are the few trade-offs with the current products. And then as I said, deployment environments, you have cloud, you have on-premise. There are multiple options that you're going to see, you're going to continue to see going forward because there is a lot of investments that is happening in the hardware in developing custom chips for deep learning, right? For example, Apple has launched custom chip for iPhone. So iPhone is going to become like a Fabian intelligence, wherein you can process then and there in your iPhone rather even going to the cloud. So you see all these new hardware that will come into the market that going to revolutionize or even change all your assumptions that you have today towards the hardware. And then as I said, task level versus high functional. So task level is an outcome of a single neural network. High functional meaning it should be able to do very complex tasks, which involves multiple neural networks. There is a decision flow between the neural networks, but it still is a single API input and single API output. In that case, your complexities become exponential, as I said, because you have to have production systems for different models, and you have an application server that manages the API distribution. So you need to have those kind of complex architectures to build a high functional API. And then learn and relearn concept, right? As I said, your workflow, be it workflow tools or be it your customer applications, every day you're receiving new data and you have to retrain the models. You cannot just depend on saying that, okay, I have trained my model in the past 1 year's data and I use the same model as a recommendation system for next 6 months. It may or may not gonna work out depending on your user activity, right? And the dynamicity of your user activity. And when it comes to workflow tools or decision intelligence, so you need to get feedback and you need to get updated with the feedback so that you have the best trained model and you have the most updated model. In that case, you have to retrain your model in a very quick amount of time. Currently, it's a very manual process. For example, if I have to replace my, let's say, fraud detection module, it takes more or less the same time as building a new module. So those are huge trade-offs when it comes to building an autonomous applications. And then as I said, product strategy, right? For example, is the data sets available? If the data sets are not available, then how can I manage to build or how can I manage to use deep learning in my current application? Can we use, reuse and use the intelligence that I have built? For example, I might have built a product recommendation model. Can I use it elsewhere? I might be using it only for product recommendation, but can I also use it for some other purposes? You can use it for example, pricing personalization. You can use it for multiple cases wherein it might have trained on a different data, but you can use a feature set for predicting another different task. Those are the another questions. And then would there be multiple APIs that I need to build? If I have multiple APIs that I have built in my application, then I have to manage all of those APIs, right? Can I converge all that small APIs into a big API? So then it becomes easier to manage. Then it becomes easy to integrate also. And then can the APIs change in future? For example, today you might be using some vision API, some API, but tomorrow there might be another API that might have beaten the accuracies of your current API, be it in internally or also in external APIs, right? In that case, how easy and how simple for me to change that API such that I am getting the best output and at the same time my product is not disturbed too much. So these are the few things that has to be thought about when you design a product, primarily in deep learning based product designs. There is a short-term leverage. For example, I can quickly build APIs and put into production. At the same time, when you do that kind of task, then you end up building multiple APIs, and you need to put in a lot of effort in terms of managing it. At the same time, you need to manage your internal team itself, right? Who is building what? Can I leverage it elsewhere? Why does I have to build an API from scratch? I already have an API. Can I use it somehow and then to build a new API? So there are multiple things that comes into picture when it comes to product strategies in short-term goals and with long-term goals. So those are the few challenges in deep learning, and for us, we are trying to address that with three simple strategies or three broad strategies. So one is we wanted to make tools easy and simple, so that your prerequisite of the user shouldn't be a researcher. So you should be a normal data scientist, and you should be an even expert data scientist. You should be able to build a network in a very short amount of time. So that happens when the tools are simpler and when the tools are intelligent enough that could help you to build a good neural network. And the next thing is reduce the time from building a network to production by automating complex data science tasks, be it in parameter optimization or be it in production system maintenance or API management use cases. See, in all those things, you can actually automate those tasks. You don't need another person to manage all those things, right? If you have a good tool and a good platform, you can able to automate it. And at the same time, we wanted to create an ecosystem of micro apps and microservices, meaning any API is not enough for any company, right? You always need to have another delta that could able to give you the value. For example, if you are a startup and you have good amount of data, you want to retrain your model on the previously available data. Or if you don't have data, then you want to look for sources where you can gather data or you can communicate the data. So there are multiple things wherein you might always are looking for delta so that you have your own differentiation. So that delta can be offered by microservices or micro applications. So that's where we are trying to invest in creating an ecosystem of data sets, ecosystem of trained models, ecosystem of neural networks, and ecosystem of talent, such that as an enterprise I can leverage the platform and build multiple products at scale. So this is our strategy in terms of trying to address the problem. And architecture primarily might look something like this, wherein we have Arya as a platform, and on that platform we have three broad phases. One is building networks, training networks, and scaling inferencing systems. So if we have data connectors primarily to connect with your current data platforms. For example, if you are using big data platforms like Kubel or something of that sort, and I have my own data in Hadoop cluster or Spark, you can stream the data through data connectors to Arya platform. So this is more like a plug and usable. You can connect your data and then you can build a model on Arya, and Arya can start reading data from your current data platforms. And then when it comes to building a neural network, so we have a GUI framework. In fact, we'll talk more about it. So we have three as a broad features on Arya platform. The key thing, the primary thing is the building a neural network, right? How can I help an advanced data scientist and how can I help a beginner data scientist? I have to address both the audience at the same time. For an advanced data scientist, he wants to build a very complex neural network, and he doesn't want to take too much time in building a good neural network. So in that case, the framework actually helps you to build a very complex neural network in a very short amount of time, and at the same time, it has better debugging tools. For example, when I build a neural network, I don't know whether the neural network is properly defined or not. So typical process is you run the training and you see if it failed, then you understand, okay, something is wrong in your neural network, right? So instead of you trying to understand the success of your neural network after giving you some training data, you can actually test the network then and there. So this helps a very advanced data scientist or a researcher to build a very complex neural network. At the same time, for a normal guy, it becomes like a drag and drop module or drag and drop task. So he can quickly drag and drop the layers that you want and design the architectures. So this simplifies a lot in terms of building a neural network. And at the same time, we also have transfer learning concept. For example, if I have a trained model outside, I can plug it into this framework so that I can use that in building a new neural network. And then we have simulation AI, primarily for network testing and parameter testing. So let's say I have 4 or 5 neural networks, and each neural networks I have a variable, right? I have to choose what is the learning rate, I have to choose what is the epoch and what is the batch size, and then you have multiple options of neural networks. So if you wanted to test your neural network on your data sets, that can be completely automated using the platform. So simulation AI is what we are offering, and there are other tools that you might have used or you might have heard about, like AutoML is one of the tools, and then H2 offers Driverless AI. And then Bonsai has a reciprocative neural network framework. So there are multiple open source tools / premium tools that are available that is primarily investing a lot of resources in parameter tuning and in building the models. And then when it comes to production, right, for example, we wanted to become cloud agnostic and hardware agnostic. I should be able to deploy my model, one model in Google Cloud, one model in Amazon, one model in Azure, and still able to manage all that APIs through single interface. So that's what Arya offers you. It simplifies a lot of tasks in terms of testing your model on multiple environments and then optimizing your production system maintenance or even your training servers, right? So Arya actually is trying to optimize the resource requirement also. For example, tomorrow if I wanted to scale to production, let's say my use case is image classification, right? Or my use case is photo classification wherein I need to have huge throughputs. So in that case, which hardware would work or which cloud environment would work, which configurations would work. So all those things can be automatically optimized by Arya platform going forward. And then we have Sandbox Server. So Sandbox Server is primarily helping you to build high functional APIs in a very quick amount of time. So for example, I have, let's say, 4 modules in Arya, and then I build another 3-4 modules outside, or even I want to use some external API. So you can even build that complete application with decision flow by defining those API and API outputs using Sandbox API. And then we are actually currently trying to build an autonomous learning applications. For example, once you go to production, so you can give access to your database and the system can start relearning on live, meaning let's say I built a model in Arya and then Arya has access to my production system database, right? So whatever the new data set that you have received, the model can retrain and replace the model. Again, replacing the model depends upon multiple factors. Is my accuracies are improving or is my accuracies are dropping out? So all those tasks can be automated using Arya. So this is actually in beta phase wherein we are testing with some enterprise applications which is already in production, meaning whenever there is a feedback, it's automatically retrained and you're seeing a new module at every point of time. So all your retraining is more or less automated using Arya. So for example, if I wanted to test, so let's say, as I said, building networks is much more simplistic, right? And testing neural networks. So I can start off with AlexNet as a starting point, for example. And I wanted to see what if I add 1 more CNN or 2 more CNN layers or 3-4 CNN layers. I want to test with same hyperparameters. I want to understand what are the hyperparameters that would work for new networks. In that case, you can just add 1 CNN and define that logic in the drag and drop framework, and then you can start running the testing. In fact, I can run any number of testing at the same instant. For example, today, let's say I built 4 or 5 neural networks by changing AlexNet to able to optimize and to give me better accuracies that can work for my task. And then I can run the modeling at the same instant. And it doesn't take too much time to complete the training process. It might take minutes or hours depending on your quantum of training data. But at the end of the training, you will get the output for all your models, and then you can correlate which network is working, which network is not working. At the same time, as I said, we have hyperparameter tuning, right? So the variables can be your learning rate and the batch size and epochs or NNs. So for which network, for which parameter, I'm getting the better output. So all those parameters will help you to design the production system again. And at the same time, we have single-click production system, meaning I can scale my model into a production API. And you can also define where you wanted to create the API, at the end of the output layer or in the middle of the layers, such that you can use that feature API for another network. Same thing for using parameter optimization also. I can build a production system through a single click model. So this might be your product stack for big data or ML stack primarily, and this might be the deep learning stack. For example, the key changes will be in how you are searching your data. So you can use MapD kind of tools to search heavily on your data for a large quantums of large quantums of data using GPUs as a backend. At the same time, what we are trying to do is replacing API's requirement, API management requirement, and able to use Arya as a single system so that you can optimize, and Arya can optimize all your major complex tasks. There are a few, so one of the enterprise examples that we have built for one of the large insurance companies, and the application that is already available on the platform is health claims automation. So today, health claims automation is a manual process. It takes a lot of time and there are a lot of frauds. Even though there are modules available out there, statistical/ML, it's not up to the mark because there is too many input parameters, and you have a varied amount of dynamicity in your policy information and how people are reacting to that information, right? So those are the few challenges with the current modeling and the current business challenges. So, and the other business challenge is also loss of value. For example, today there is a huge amount of leakage in claims. Meaning, if I'm an insurance company and if you say that you are applying for 10,000 rupees claim, I might say that okay, you might not require 10,000, you might require 8,000 rupees, or I might pay you more. As an insurer, I'm losing value there, right, by overestimating the value or underestimating the claim. So those are the few challenges in the industry, and there is a huge amount of frauds and the variability in the frauds also. So that's why we have built a very large neural network. It's one of the massive neural network that we have built, which captures a lot of feature set. So the the number of parameters that goes as input into the neural network is more or less about 460 plus. And there is a different networks that is addressing for different types of data. And all of the data is being converged into a single neural network later on. And after training this model on the claims, we have gotten the precision of about 95 to 96%. And recall is also more or less in the same perspective, meaning it can able to identify a fraud and it can say that it's a fraud, or it can able to settle the claim, and it can able to settle the claim at the utmost amount of accuracies. Yeah, so and it can process a claim in less than 0.04 seconds, and this is still in a single server GPU. You don't need massive amount of GPUs to be able to go to production. You can able to optimize your hardware in a very short within the resources, and you can have STPs. STPs meaning how many cases an automated system can handle, how many cases where you need a human input. So currently the system can handle at least 80 to 85% processes by itself without the input of any human. And at the same time, we are now capturing data set for that rest of the 15%, so that it goes as a feedback data into the system, and the system can keep on training. And it's much cheaper anyways. As I said, it consists more than 500 plus parameters, and you can continue to increase more and more parameters, and it can learn autonomously. It can flag frauds in a very quick amount of time. Architecture more or less looks like this, and it's a single API. All the decision that is happening from Arya as a single API, but in the backend there are another major neural network, but you are still communicating through a single API output. And at the same time, we are also using the same intelligence for multiple other purposes in the same organization. For example, I can use the claims information to optimize my underwriting. So because I have a better understanding of where I'm losing a value, right? If I see the same case in a new claims, I can understand this is where I'm losing the value, and this is where I might have to price it more. So those are the cases where I'm using